In this video, I will introduce the concept of taking the union of sets. Suppose we have two sets, A and B. We can then define the union of A and B, which is represented by the symbol A union B. So this entire symbol represents a set. So the union is defined to be the set consisting of elements that are either in A or in B or in both A and B. So what this means is that X is an element of A union B if and only if X is an element of A or X is an element of B. And we can also express this idea by using set builder notation by writing A union B is the set consisting of the objects X such that X is an element of A or X is an element of B. And note that the OR that you see here in this statement also includes the case where X is an element of both A and B. So this OR over here includes the case where X is an element of A, and the case where X is an element of B, and the case where X is an element of both A and B. Now let's take a look at an example. So suppose A is defined to be the set consisting of the numbers 1, 3, and 5, and then B is defined to be the set consisting of the numbers 1, 2, and 3. In that case, A union B is the set consisting of the numbers 1, 2, 3, and 5. And that's because you can see that, first of all, the number 2 shows up in the set B, and the number 5 shows up in the set A, and the numbers 1 and 3 both show up in both A and B. And so that's why we include these numbers inside A union B. So you can understand A union B as sort of combining the elements of both of these sets and then omitting the repeated elements, because in a set we do not care about repeated elements. So you can think of A union B as a process of combining two sets. Here's another example. Suppose A is the set consisting of the numbers 1, 2, and 3, and B is the set consisting of the numbers 1, 2. In that case, A union B is the set consisting of the numbers 1, 2, and 3. And that's because you can see that both 1 and 2 show up in both A and B, and then the number 3 shows up in the set A. And so that's why these three elements are in A union B. And you can see that for this particular example, there are no elements in A union B that only show up in B. So you can see that 1, 2 show up in both A and B, 3 shows up in A, but there are no elements that only show up in B. So this is slightly different from the previous example. Let's take a look at one last example. Suppose this time A is the set consisting of the numbers 1 and 2, and B is the set consisting of the numbers 3 and 4. In that case, A union B is the set consisting of the numbers 1, 2, 3, and 4. And that's because the numbers 1, 2 show up in the set A, and the numbers 3, 4 show up in the set B. And so that's why A union B is composed of these elements. And you can see that this time there are no elements that show up in both A and B, but that still does not stop us from taking the union A union B, which is just this set that you see over here. Now here are some interesting identities we can derive concerning the union of sets. For example, the union of a set with itself is always just equal to itself. So the union of A and A is just equal to A. Also, the union of a set with the empty set is just equal to itself. So the union of A with the empty set is just equal to A. Also, the union of A and B is just equal to the union of B and A, so the order doesn't matter. And the technical term to describe this kind of behavior is to say that set union is commutative. And you can see that this is kind of similar to addition, because in addition we know that 1 plus 2 is equal to 2 plus 1, so the order doesn't matter. And the technical term for this is to say that set union is commutative. Now another interesting result is that set union is associative, and what that means is that suppose we have three sets, A, B, and C. We know that A union B and then union C is equal to A union of B union C. So the order of taking unions does not matter. I can start off with the union between A and B, and then take the union between this set and C, and then, or I can also start off with the union of B and C, and then take the union of this set with A, and then no matter what order I take these unions in, I will still get the same outcome. And then we describe this kind of behavior using the technical term associative. So we say that set union is associative. And once again, you can draw a parallel between this kind of behavior and addition, because for addition we know that 1 plus 2 and then plus 3 is always equal to 1 plus and then 2 plus 3. So you can draw a parallel between set union and addition. You can see that addition is also associative.